All right, guys, for Unit 11B, which is our volume unit, I decided to make a review video for it. So going through what I would consider some of the problems I get questions about year to year, or which ones I anticipate would be the hardest for you. So I'm going to go through the video. I'll scroll through so you see which problems I go through. So 1, 2B, 2D, question 3, question 4, 5, 6, 7, 8. So basically that entire second page. All of question 9, 12, got 13, 15, all of 17, all of 18, and all of 19. So you'll see that I actually go through a lot of this packet. And I know that the last 3 questions are probably where you'd have the most questions as well, because these are questions that I have taken or modified from what I've seen as Regents questions in the past. All right, going back to the beginning. All right, now first thing to remind you of is you will have your Regents reference sheet on this. So actually, maybe I should scroll to where that is. Whoopsies. Okay, so here is your Regents reference sheet. It's got some conversions up here, which might be helpful. We've also got our volume formulas, which happen right in here. See everything that says V? These are your volume formulas. Now, when it says general prisms, any prism is the volume, or the volume is equivalent to the area of the base times the height. And it is important that you use capital B in your computations. Lowercase b means length of a base. So yeah, I'm not going to give you the volume formula for a hexagonal prism. I'm going to expect that you understand you have to find the area of the hexagon and then multiply it by the height of the prism. They do give you cylinder though, which makes sense that it's pi r squared because that's the circular base area. Sphere is given, but you know what's not given is hemisphere. Remember, hemisphere is just going to be half of this. You could either multiply it by 1/2 or write this as 2/3 pi r cubed. And please make sure you write cubed. On your quizzes, some of you guys wrote squared even though you had the reference sheet. Probably because you're used to doing area equals pi r squared and didn't even realize that you were writing it wrong. Cone is here. It's always 1/3. As well as pyramid, it's always 1/3. If you remember that visualization that 3 pyramids will fit into 1 prism, you know, of equal base area, equal height, that video I showed you guys in class, that's why a pyramid is 1/3 area of the base times the height. Okay, so those are important. I could ask you about circumference, in which case that's here. Like I could give you the circumference of something, ask you to find the radius, and then here is the area of a circle, which you guys should already know. So these are your area formulas, this is your circumference formulas, and these are your volume formulas. You really shouldn't be touching anything over here. This is all Algebra 2 content. Okay? The Pythagorean theorem is here, which you may use in some problems as well. I'm going to push you in this unit. I will give you some problems that are going to make you have to use strategies that we have discussed in the past. And I've done the best job I can to expose you guys to those types of problems throughout not only this review sheet, but also the questions that I've given you in the notes and on your homework. So those are going to be really important problems to look over as well. All right, our answer keys are down here. I'm ready to go back to the top again. All right, find the volume of a hexagonal prism whose base side length is 3 inches and whose height is 5 inches. Note that the units are the same, so I don't have to worry about any sort of converting. I want to round to the nearest hundredth. Volume of any prism is area of the base times the height. Since it's called a hexagonal prism, that's your base. Hexagons have 6 sides. Okay. I said each base side length is 3. Now what's important to note is that the central angle, which would be 360 divided by 6, is 60 degrees. And we've discussed this a lot, especially in the last 2 units, that these are actually equilateral triangles, because these radii would be congruent, which means these angles must be congruent. There's 180 degrees in a triangle, so those must also be 60. So 60, 60, 60, that is an equilateral triangle. So with that being said, I know each of these radii are going to be 3 inches as well. And that's going to be important in my computation of area of the base. Area of the base is 1/2 AB sine of C. That's your area of a triangle. But there's 6 triangles here, so I'll have to eventually multiply by 6. Okay, now it tells me the height of the prism, which you imagine would be, if it was like going into the page, would be 5 inches. Okay, so if volume equals capital B times H, I'm going to take whatever this computes to, plug it in for B, and the height they told me was 5 inches. So it's the height of the prism. All right, and then it's just a plug and chug. All right, now note how I plugged in my calculator. 1/2 times 3 times 3, which is 9, times sine of 60. I close the parentheses, then times 6. Otherwise, that'll mess up your answer. So you got to figure that's your capital B, that's your area of the base, so 23, times 5, and that's how I'm getting an answer of 116.91. Coming up next is 2B. This is a triangular prism because the triangles are the bases that are parallel to each other. And in fact, this is a right triangle. Now, in order to find the area of the base, you'd need some angle measures, which isn't going to happen here, or our traditional area formula, which would be 1/2 little b times h. So right now what I can see is the height of this triangular face is 9. See how it meets with the perpendicular other side? So this would be your base. Okay? I don't know how long this is, and they didn't give me any information about that side length. Otherwise, those would be equivalent. But what they did give me is that this part right here is 15, which means this part is 15. Note how those are parallel to each other. That's how they're congruent. Okay, now here's where, again, I push you. How do you find that side? This is where we have the Pythagorean theorem, and that's why it's on your reference sheet. It will come up. You should know it by now, though. You shouldn't have to look it up. So remember, A and B are the legs. They're the shorter side. C is the side opposite the hypotenuse. C is opposite the right angle. It's the hypotenuse. Some of you guys are guilty of mixing up those. So please make sure you're plugging into the Pythagorean theorem correctly. So I've got x squared plus 9 squared equals 15 squared. Okay, so you're going to be doing 15 squared minus 9 squared, which is 144, and that should be ringing bells in your head because that's a perfect square, which is 12. So at this point, I know that's 12. That looks like 112. Okay, so that's what's going to go in for little b in the area of my base. 9 goes in for little h there. Okay, so area of the base is going to be 1/2 times 12 times 9. Don't forget the 1/2. A lot of people forget about that. I multiplied wrong. 12 times 9. Notice how I checked over my work there. Times 1/2. Okay, 54. Okay, volume of any prism is area of the base times the height. So 54 times the height of the prism. So again, height of the prism is really the distance between the parallel bases, is another way of thinking about it. The distance between the bases is 7 centimeters, and that's why I'm plugging 7 in. So I got 54 times 7, and I'm getting 378. Technically centimeters cubed. Now, if you didn't put on your units, that's okay. If you do put on your units, great. Where I'd have to take off is if you wrote something like this, because that's wrong. It's not squared, it's a volume. I'd also have to take off if you did this. Problem wasn't in millimeters, it's in centimeters. So, if you're not confident in writing the right unit, just write 378. Okay, but I do want you to pay attention to units just in case I did have mixed dimensions, which you will see somewhere in this packet. All right, next we've got letter D. Now this is a pyramid, which means our general formula is 1/3 area of the base times the height. The 1/3 is the most missed part of this, okay? The base is actually an equilateral triangle. You guys see that? Okay. So with that being said, I'm not going to find the area of the base, the triangle, using our traditional 1/2 base times height because I don't know the height of that triangle. And I could do some trigonometry to find it, but honestly, that's much harder than recognizing that each of these angles is 60 degrees. Here are the two sides that include that angle, so I can just use 1/2 AB sine of C. Okay, so our base is 1/2 AB sine of C, and it's just a triangle. I'm not multiplying by anything. 1/2 3 times 3 times the sine of 60. Okay, whatever that is, I'm going to plug in here. And the actual height of our pyramid is there, which is the difference or the distance between the apex of the pyramid and the parallel base. And that's perpendicular distance because this appears to be oblique. Okay, so 5 is going to end up going in for H. All right, so in my calculator, I've got 1/2 times 9 times the sine of 60. Okay, so that would be my capital B times 1/3 times 5. 6.5. Should I have rounding directions here? Yeah, 6.5. Okay. 6.5 centimeters cubed, technically. All right, find the radius of a sphere whose volume is 2304 pi inches cubed. It's really important you don't forget the pi, because what this is 2304 times 3.141592 ... Okay, so the volume is actually larger than 2,304. It's almost 3 times as large. So it is important to include the pi here, and that's one of the biggest mistakes students do. So they're talking about volume, right? So that means, using my reference sheet, I know that's 4/3 pi r cubed. Now, you really should have these memorized. That's going to get you to go faster on this test. You know, you're going to be slow if you have to look up every formula, but it is there as a cross-check in case you're not confident. Okay, so 2304 pi goes in for volume. Now, here's the good news. When you divide by pi, they're going to go to 1, so those drop out. In order to get rid of the 4/3, I'm going to multiply both sides by 3/4. 1728. Okay, and then I have to find the radius. This is older software, I think. So if I hit math, oh no, it's there. Good. Math option 4. Cube root of, what was it again? 1728. C's. 1728. 12. There you go. And I would always give you guys a nice cube root there. I wouldn't give you something weird. All right, a composite solid is a three-dimensional figure that's composed of simpler figures. Find the volume of the composite solid in the diagram below, round to the nearest hundredth. All right, so what I'm seeing here is a cube. You guys see that? This is your cube. And then this looks like half of a cylinder. Okay, so starting with the cube. Cube is just s cubed. It's going to be area of the base, which is side squared, times the height, which is just going to be s again because the dimensions are the same. So side cubed is a nice formula for a cube. So 12 cubed, which, oh hey, look at that, I already know is 1728 if you look at my last problem. 12 cubed is 1728. Okay, now I have to add that to the volume of half of my cylinder. And this is where they don't give you the volume for half of a cylinder. You know the volume of a cylinder is pi r squared h, because it's area of the circle times the height of the prism itself. And then since it's going to be half of it, I'll tack on a 1/2 in front. Okay, the radius would be right in here, which would be 1/2 of 12. Look at those sides, see how they're parallel to each other, so they'll have the same measure. And the height of it would also be 12. At the end of the day, they want me to round this to the nearest hundredth, so I'm going to take these and add them, because that would give me my composite solid. Oops, I forgot my squared in here. That's important. It's a common mistake. 6 squared times 12. 1/2 pi r squared h. Okay, good. 2406.58. Technically centimeters cubed. All right, next, number 5. Find the volume of a square pyramid with a slant height of 13 inches and a base length of 10 inches. Because it's a square pyramid, that tells me the base is a square. Pyramid means the faces are triangles. They meet up at a single point. Okay. Now, slant height is the distance along the face. So that's 13. Base lengths are 10. Okay, so volume of a pyramid is 1/3 area of the base times the height. Now, base won't be that hard. That's just 100 squared. Or 10 squared, excuse me, which is 100. Okay, that's really not a big deal. What's a big deal here is I don't know the height of this. You cannot use the slant height here. So, erase this for a second. Whoopsies, erased too much. Okay, in order to find the height, I'll call that h, this distance right here would be 1/2 of 10, which is 5. Okay, there's your Pythagorean theorem. So, I'm going to have to do h squared plus 5 squared is equal to 13 squared. So that's 169 minus 25, which is 144. So my height is 12. And this is really important. This is the biggest mistake students make. Okay, so now from there, volume is 1/3. We just said area of the base would be 10 squared because it's a square, 10 times 10. And the height we just found was 12. So 100 times 12 divided by 3. Oopsies, that's not right. Well, 100 times 12 is 120. Divided by 3 is 40. And there you go, 40 inches cubed. All right, 2 similar cylinders have radii of 15 inches and 6 inches. What is the ratio of volumes of the small cylinder to the volume of the large cylinder? So what they're giving you here with 2 similar cylinders are radii. Those are corresponding side lengths. So think about that as like your side 1 and side 2. When I want the ratio of the volumes, it says in the ratio of the small cylinder to the large cylinder. So actually maybe I'll switch this. Small to large. Okay, you just need to remember to cube it. The relationship is side 1 over side 2 cubed is V1 over V2. So in the same order, so it says from small to large, 6 over 15 cubed, and then you just go ahead and cube it. Okay, I won't finish that. I think it's what, 216 over 225, I think? Well, now I have to. Now I'm annoyed. 15 cube's way bigger than that. What am I thinking? 375. I think 6 cubed is 216. Yeah, 216 to 3375. Okay, while I'm at this, keep in mind that we do know side 1 over side 2 equals P1 over P2. Doesn't come up as much in this unit, but be aware we know that. And we also know side 1 over side 2 squared equals A1 over A2. And that has come up in this unit. So be aware. Alright, a shipping container is in the shape of a right rectangular prism with a length of 12 feet, a width of 8.5 feet, and a height of 4 feet. Container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. What is the weight in pounds of the contents of the container? So it doesn't straight out say find the volume, but when it talks about completely filling something, that's volume. So a rectangular prism, remember, looks like this, and they're telling me the length, width, and height essentially, which I don't even need the visual here, but just to, you know, kind of tie everything together, this is your visual, and area of the base times the height. Since it's a rectangular prism, it's really not clear what the base is, but it really doesn't even matter because it's going to end up being length times width times height. So 4 times 8.5 times 12. So 408. And then this is feet cubed because all my dimensions were in feet. Now it says that the contents that it's going to be filled with weigh 2.5 pounds per cubic foot. And the good news is this is already in terms of cubic feet. So if you had 1 cubic foot, you would have 0.25 of a pound. But you don't have 1 cubic foot, you have 408 cubic feet. So 408 times 0.25 pounds is what's going to give you the weight of the contents. So I'll take that, multiply by a quarter, and that's where I'm getting 102 pounds from. Okay, number 8, a cube with side lengths of S has a drill pass perpendicularly through it, removing the shape of a cylinder, which has a radius of capital R. Write an expression in terms of R and S that best estimates the remaining volume of the cube once the drill passes through. All right, so let's say here's your cube, S, 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 and you're going to take out a cylinder, passes completely through it, with a radius of R, which and will also have a height of S because it fits perfectly in the cube. Our volume would be volume of the cube. Take away the volume of the cylinder because that's what you're getting rid of. Our cube would be S times S times S, or S cubed. And our cylinder formula, remember, is pi r squared h. But in this formula, it's going to be pi capital R squared, because that's what they've defined the radius to be. And the height we just said is S. So that's your expression in terms of R and S. All right, prism A has a height of 5 and a mass of 1,000. Similar prism has a height of 7 and a mass of 2,744. So height of 5, mass. Height of 7, mass. They also then gave me a volume, which is 686. That's of prism B. I want the volume of prism A. Okay, volume of these similar figures can be calculated by using our side 1 over side 2 cubed equals V1 over V2 idea. They gave me the height of prism A to be 5, the height of prism B to be 7. So those are your corresponding side lengths. I don't know the mass of prism A, so that'll be my X, but I do know the did I say volume? I don't know the volume of prism A, so I call that X. I do know the volume of prism B, though. Okay, so now I have to solve. 5 cubed is 125. 7 cubed is, I want to say, 343. Please be right. Please be right. Ah! Yes, 343. And I did do 5 cubed, right? Just double checking. All right, great. Okay, and at this point, you guys can cross multiply, solve for X. Something that you may have learned in middle school is a nice little other way of solving. Do you notice how 343 is half of 686? So like in order to get over there, you'd have to multiply by 2. So that means X is whatever 125 times 2 is, so 250. So just something to notice, something that's a little bit faster than cross multiplying sometimes. All right, so Courtney thinks that the two prisms have the same density. Adam says prism B is clearly denser because it's bigger. Who do you agree with? Well, density is calculated by mass divided by volume. So for prism A, let's see, they have a mass of 1,000. And we just found the volume of prism A to be 250. So 1,000 divided by 250 is 4. I don't have any units here, so I guess it's units per units. I don't know. Units, I guess it was in terms of centimeters. Yeah, I probably could have done a better job with the units on this problem. We'll just say the density is 4 for right now. For prism B has a mass of 2,744 and a volume of 686. Oopsies. Oh my goodness, why do I keep typing this wrong? 2,744 divided by 686. 4. Ah, there we go. So who do we agree with? Courtney. The density are equal. And when it says justify your answer, that just means show your math. And that's exactly what I did. This is my justification. I just convinced the grader that the densities are equivalent. All right, a right rectangular prism with a base of 4 meters by 9 meters has the same volume as an oblique rectangular prism with a base of 6 meters by 6 meters. Okay, so essentially, here's one. It says its base is 4 meters by 9 meters. And I've got another one that it says is oblique, so maybe I'll make this look more dramatic, whose base is 6 by 6. Now, these two prisms, which is important to know, it's not a prism and a pyramid, it's two prisms, have the same volume. What can you conclude about the heights of these and why? Well, what's important to note here is the bases. If you calculate the area of the base of each of these, 9 times 4 is 36, 6 times 6 is 36. Their base areas are equivalent. If their volumes are equal, their heights must also be equal. Their volume formulas must check out, and this is Cavalieri's principle. So, since volumes are equal and base areas are equal, their heights must also be equal. And if you're saying the base areas are equal, you really need to show that they're equal, which is what I did here. If you didn't show that 36, I would take off a point because you're not convincing me that their base areas are equal. Okay, if they are equal, what are they? You know what I mean? So you got to make sure you're showing your work, convincing the grader. All right, number 13, find the volume of a sphere with a circumference of 8 pi centimeters, round to the nearest tenth. So circumference on your reference sheet is 2 pi r or pi d. Either one honestly will work. I tend to like 2 pi r because you're eventually going to work towards your volume formula, which is in terms of the radius. So not that it matters, diameter is just twice the radius, but something to consider. So circumference is 2 pi r. I'll set that equal to 8 pi because that's what it says that it is. My pi's drop out. 8 divided by 2 is 4. Oopsies. Sorry, I wrote the wrong number. So my radius is 4. Okay? That's what then goes in for here. Okay, and it says round to the nearest tenth, so you just plug this entire thing in. I think you guys are good with the plug-in, so I'll leave that for you. All right, the volume, or excuse me, two similar hemispheres, A and B, have surface areas in the ratio of 4 to 25 respectively. What is the ratio of their volumes? Surface areas in comparison to side lengths are the squares of the corresponding side lengths. So if they're giving you the areas ratios to be 4 to 25, that means in order to solve for side 1 over side 2, you'd have to take the square root. So side 1 to side 2 is 2 to 5. Okay, so why is this important? Because you're eventually going to go towards the volume ratio. Side 1 over side 2 cubed is V1 over V2. So now I'm going to plug in 2/5, cube them. 2 cubed is 8, 5 cubed is 125, and that's your volume ratio. All right, a snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice, as shown in the diagram below. The inside diameter of both the cone and the hemisphere is 8.24 centimeters. The angle at the tip of the cone is 44 degrees. Determine the height h of the cone to the nearest tenth. Okay, so they have labeled for you where h is, which would be the same as if you split this triangle or cone right down the middle. So what I'm visually thinking of right now is splitting this in half. That's a terrible drawing. I guess I'll just focus on here. This, which would be half of an isosceles triangle if you think about it in 2 dimensions. So for those dimensions, this would be h. Half of 8.24 is 4.12 centimeters. And do I know this length? I do not. I do know this angle though. This whole angle is 44, which means half of it is 22. I have just enough information to solve for h by using trigonometry, and I can do so within this right triangle. I couldn't do trigonometry SOHCAHTOA style if it weren't for having this right triangle. Okay, so from here, from the angle, I have the opposite and the adjacent side. So tangent of 22 is equal to 4.12 over h. So I'll do a little bit of a rearranging here. So in order to solve for h, I'd have to take 4.12 and divide by tangent of 22. Make sure your calculator is in degree mode, which it is. Okay, so I'm getting to the nearest tenth, 10.2. Okay, how much ice is needed in each snow cone? Round to the nearest hundredth of a cubic centimeter. Okay, so I'm still doing everything in centimeters, which is good. Now keep in mind, you're going to be filling the cone, so you'd need the volume of the cone. And you'd also need the volume of the hemisphere, because that's ice as well. All right, so starting with the cone. Volume of a cone is 1/3 pi r squared h. The radius, as I already mentioned, would be 4.12. And the height I just found in the first part was 10.2. And sometimes you guys ask me, do I use the 10.2 or do I use the unrounded answer? If they're asking you in the problem to round, then it's implied that you can use that rounded answer in the next part to make your life a little bit easier. Okay, so I'll eventually plug that in. Going over the hemisphere, volume of a sphere is 4/3 pi r cubed. Half of that would be 2/3 pi r cubed. And they said in the problem that the diameter of the cone and the hemisphere were the same, so the radius is still going to be 4.12. Oopsies. See, I pulled a mistake that you guys are used to. Cubed. Okay, so in my calculator, I just plug it in. All right, so I paused to save some time. I plugged in my expression. Let's hit enter. 327.78 cubic centimeters. Now, just so you guys know, I just double checked my answers on the back page, and I accidentally put a $sign there where there shouldn't be a $sign. It's not the cost. We haven't gotten there yet. That's just the volume, so my apologies for that. So 327.78. The next part has to do with cost. If shaved ice is 0.697 grams per centimeter cubed, this is good news, guys. We're already in terms of centimeters cubed. And the cost then per gram is 2 cents, determine and state the cost of ice needed to make 50 snow cones, round to the nearest cent. All right, they gave us a lot of information here. So let's start with just figuring out how many grams of ice we would have, because they gave me a conversion in terms of grams, which relates to centimeters cubed, which is what I already have. So I have 327.78 grams per centimeter cubed. Oops, I'm sorry. Centimeters cubed times 0.697 grams per centimeter cubed. When you multiply centimeters cubed by essentially 1 over centimeters cubed, those drop out, and that's what leaves you with the amount of grams you have. So 327.78 times 0.697, 228.46226. I think that's right. Make sure I copied it right. Good. Okay, so this is how many grams you have of ice. Then it says the cost per gram is 2 cents. And this is where you need to make sure you're multiplying by 0.02. Okay, so take my answer, multiply by 2 cents, because it's 2/100th of a dollar, and I get 4.56. ... I haven't rounded yet. Now keep in mind, that's per 1 snow cone. Okay, and some of you guys have asked me, how do I know to multiply by 2 cents as opposed to divide? It's saying it's 2 cents per gram. So if you had 1 gram of ice, it would cost you 2 cents. But you don't have 1 gram, you have 228. So it makes sense then to take 2 cents and multiply by however many grams then you have. Okay, so then going back. So it's about $4 to $5 for 1 snow cone, but you're making 50 snow cones, so we have to take that cost, multiply it by 50. To the nearest cent, it looks like we're doing $228.46. All right, when volleyballs are purchased, they are not fully inflated. A partially inflated volleyball can be modeled by a sphere whose volume is approximately 180 inches cubed. After being fully inflated, its volume is approximately 294 inches cubed. To the nearest tenth of an inch, how much does the radius increase when the volleyball is fully inflated? Ooh. Okay, so essentially you've got a small sphere and a bigger sphere, and he's inflated more. The volume of the smaller sphere is 180. The volume of the larger is 294, both in terms of inches cubed. I want to find the radii of each of them, and then I'm going to find how much they change, so how much difference is between them. So starting with the small one. Volume is 4/3 pi r cubed. I know the volume is 180. Okay, so what I can do is multiply both sides by 3/4 to get rid of that fraction. So 135. I would have to then divide by pi, and then take the cube root. Woo! Okay, so in my calculator, math option 4, 135 divided by pi. Okay, so our radius is about 3.502. Notice I'm not rounding yet. I'll do the same exact process with the large one. Actually, in terms of x, I guess, because I called this x. Okay, and then I just have to take the difference of those. So I had that. Take away, fortunately I have an old software calculator up here, so I'm just going to type out that decimal. I can't go up and grab it, unfortunately, and I didn't think to store it. 0.026, okay. So point, what did it say to round to? Just the nearest tenth of an inch, 0.6. Hopefully I didn't make a mistake, gotta double check my key. And I did it right. Yay! So it increased by 0.6 of an inch. All right, last problem. I'm going to erase this so it doesn't go into the question. All right, new streetlights will be installed along a section of the highway. The posts of the streetlights will be 7.5 meters tall and made of aluminum. The rectangular prism post will have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. What is the volume of one post in cubic centimeters? Okay, so I have a rectangular prism post and it says it had a square base. So think about it like that. And the dimensions of the square base were 40 centimeters on each side. And then the height was 7.5 meters. Okay. And then they also said that it was hollow and the aluminum was 2.5 centimeters thick. So you got to imagine there's another prism in here where this distance right here is 2.5 centimeters thick, which also means that's 2.5, which means that's 2.5, and that's 2.5. So keep that in mind. So yeah, so you got like another prism inside of it that's making it be hollow. Whew. Okay, so it wants the volume of this in terms of cubic centimeters. So what's sticking out to me is this is in meters. There are 10 centimeters in a meter, so that means this is 75 centimeters tall, so make sure we're converting that. Okay. I totally just realized I said that 100% wrong. That's not correct. There's 100 centimeters in 1 meter. I'm sorry. 100 centimeters in 1 meter. Or you could think about it as Ken Henry doesn't usually drink chocolate milk. It's meters, you want centimeters, so you take the decimal and move it over 2 places. So that's how we're ending up with 750 centimeters. So vastly apologize for what I just said. Okay, so now we're in terms of centimeters. Okay, all right, so if I want the volume of the post, I would need everything but take away the stuff in the middle. So you're going to need the volume of, I'll say, the large prism, and then we'll take away the volume of the small prism. Okay, the small prism would be the stuff on the inside. Starting with the large prism. Okay, volume of any prism is area of the base times the height. They said the base was 40 by 40, and that's a square, so 40 squared. And the height is 750. Okay, so 40 squared times 750. Whoa, how many zeros is that? 1, 2, 3, 4, 5. Okay, so that's the volume of the large prism, but I gotta take away the volume of the small prism. All right, so think about this. Again, it's area of the base times the height. Use a different color here. The base is not 40 though, it's 40 take away 2.5 and 2.5. So take away 5, so I'm getting 35 for that. And it would be the same exact thing on the other side as well, 35. The height is still going to be the same height because it's completely cutting out the same shape. Actually, wait. Let me store my previous answer as X so I don't forget that. Okay, so 35 squared times 750. I get 918,750. And I just need to subtract these. So 281250. Okay, and this is technically what, centimeters? Centimeters cubed. Boom. Okay, so that's the volume of one post. Now, the density of aluminum is 2.7 grams per centimeters cubed. Again, this is good. You're already in terms of centimeters. The cost of aluminum is 38 cents per kilogram, so there's going to have to be a conversion in here, because this is grams, this is kilograms, they don't match. How much would it cost to make one light post? Round to the nearest cent. Okay, so first of all, you have 281,250 centimeters cubed for one post, right? Times 2.7 grams per centimeter cubed. When you multiply, the centimeter cubes would drop out, and that would leave you with how many grams one post is. So 759,375 grams. Now, cost is not in terms of grams, it's in terms of kilograms. King Henry doesn't usually drink chocolate milk. Okay, so right now you're at grams, but you want kilograms, which means you'd have to move your decimal, which would be right here, back 1, 2, 3 spaces to get to kilo. So 759.375 kilograms. And then it says it's 38 cents, $1 per kilogram. So we're going to take that, multiply by 0.38. Oh, actually, I should move this, right? 759.375 times 38 cents. To the nearest cent, which would be 2 decimals, 288.56. All right, so $288.56. Woo! All right, so that's the end of this video. So keep in mind, you should be looking at your notes, looking at your homeworks, which I will scan answer keys and post online to help you guys. Please study. I would say this is going to be one of the more challenging unit tests again of this. If you don't know how to use your formulas, how to convert, things like that, you will not see problems identical to what you have seen in the review or in the notes. But the strategies that I have told you guys, especially over the last few units, will tie together, and studying those, you should be able to do really well on this test. So I'm going to push you on this test. Make sure that you can think conceptually through these problems, because at the end of the day, I'm not going to know exactly what your exam looks like in June, but I will have taught you strategies to think through the problems and hopefully then have you be successful. So good luck.